at a distance L from the right side. Okay. So if I draw the free surface, okay, and by the way, it has multiple correct answers. We can say that G value will be acting downward, or rather, I'll talk about G effective first. Can I say this is going to be the direction of G effective? Yes, that's going to be the direction of G effective. Also, we know that the actual G is acting vertically downward and the pseudo acceleration is acting left side. Okay, and because they have not spoken about any angle, so let me consider this angle to be theta. So far, so good. Can I say that G effective is going to be under root of G square plus A square? Yes, everyone understands and agrees also. We have been doing this so far. Okay. So now, people, now the interesting and important part. We'll take it on the next slide also. So we have taken this angle as theta. Okay, guys. And now I'm going to join this here. And before I do that, let me just take this H here. This is H. Okay, be with me. Do you all see that H dash is basically the perpendicular distance from the layer, from the green layer, from the free surface? H dash is the perpendicular distance. Okay. It's a very important diagram for us right now. Okay, guys. Now pay attention. We need certain more things. We know that this angle is going to be 90 minus theta. So can I say that this angle is going to be theta? Everyone, can I say this angle can be written as theta because this one is 90 minus theta? Good enough. This angle is 90 degree. This angle is also 90 degree. This is A. Let's call it B. Let's call it C, and let's call it D. So the right angle triangle ACD. The right angle triangle ACD. What will I say H dash is in terms of H in this small छोटू triangle? H dash in terms of H. Is it H cos theta or H sin theta? देखो जल्दी. It's H cos theta. Similarly, in triangle ABD, AB de Villiers, yeah. H dash in terms of L. H dash in terms of L. Sine or cos? L is the hypotenuse, H was also hypotenuse. This comes out to be L sin theta. Perfect, right? Awesome. So everyone, if I will just tilt this diagram a bit, if I would have tilted the diagram a bit like this, this is how it will look like to us. Right, everyone? Why am I doing this? Because I know that this is the direction of G effective. This is height H dash, and this is point A. How will I write the pressure at A? I'll say simple. Now I see it as like my normal vertical diagrams. I'll say pressure is H rho G. So I'll say it as H dash into rho into G effective. Are you guys getting what have I done here? I have just twisted or rather rotated the diagram. ऐसा लिखोगे ना? Everybody, right? Not rotated a little. It is rotated by an angle theta in the clockwise sense. So H dash into rho, and what is G effective? It's G square plus A square. Do you understand so far, everyone? It is H dash rho into, or rather rho into acceleration, this value, and this is what we have the pressure. This is one of the answers, which is not in the options. This is one of the answers which is not in the options. Okay, and yes, one thing I have missed is the atmospheric pressure because it is open to atmosphere. It is open to atmosphere. Yes, I have to consider P dash, P ka value also. Okay, just a second, because options may be P naught. Okay, everyone. So I need to definitely respect that. P naught also has to be written there. Agree? Atmospheric pressure. Perfect. Thank you. Yes. Now switching off so that now we will write the answer in terms of H and L also. How will I do that? You see this H dash in terms of H, H dash in terms of L sin theta, L also. Okay, everyone? We'll just substitute. Yes, absolutely, we'll substitute. So I'm just taking off this diagram on the next slide. That slide is already there. There will be multiple answers correct, and that's why. Now I will be switching off the chart. So definitely a J level question. Definitely a J level question. Fluids are actually, they appear difficult, the chapter. It is not difficult if you approach in the systematic manner. That's what I'm trying to demonstrate here to all of you, that I have clear picture in my mind that, you know, fundamentals are these. I'm just following the fundamentals. And I've given you only 3 fundamentals today. One fundamental, rather 2 fundamentals are repeated from the previous class. One, that liquid will create a pressure because of the weight, right? And the more you go in the depth, liquid will create more pressure, H rho G. Secondly, the layers will have the same pressure at all the points. Thirdly, the shape of the container does not matter as long as the height is same. And fourth one has been taught today, that the free surface of the liquid will always be perpendicular to G effective. These are the 4 important points that I've taught you. We are just following them. Okay, people, so let's not get emotional more. Let me also write down the value of cos theta and sin theta. So from here in the triangle cos theta, this is going to be H square plus L square in under root. So cos theta can be written as, how can I write that? I can write the value of cos theta as L by H square plus L square. Okay. So one more thing I wanted. I just completely forgot it in the beginning only. We didn't find the value of tan theta here. Tan theta value will be equal to A by G. Cos theta value will be equal to G by A square plus G square. Do you guys get this step? Yeah, यहाँ वाले triangle से करना पड़ेगा तो कर लो. Cos theta is going to be G by A square plus G square in under root. Similarly, sin theta will be A divided by G square plus A square in under root. ठीक है? Because इसकी जरूरत पड़ने वाली है. We are going to require that. I think पड़ने वाली है जरूरत. ठीक है? Yes. So we have written the value of cos theta L upon H square plus L square, and now replacing here. So H dash is H cos theta into rho into G square plus A square, and instead of writing cos theta like this, I'm going to write that if this is G effective, this is G, this is A, this is theta. So cos theta is going to be G divided by G square plus A square. I hope you guys are still with me and not getting confused. Right? Why am I doing this? So that I can write cos theta in terms of this. Right, everyone? So see what I'm doing now. I'm just going to place the value of cos theta here and see what is happening. G divided by g square plus a square in under root into rho into g square plus a square in under root plus p naught. ठीक है everyone? Is there anything getting cancelled? Right? बहुत important conclusion derive होने वाला है. Not G effective, it is G, not G effective. Remember, it is G, not G effective. Pressure at A also came out to be H rho G plus P naught. It is also equal to H rho G plus P naught. Okay? We are not done yet. We have one more expression to find out. And now we have the expression which looks like this. So this is correct. P naught plus H rho G is one of the options that is correct. Okay? So let's quickly, let me go with a relatively faster one here. Sin theta, it's going to be A divided by G square plus A square. And I'm going to put that here. Okay? When I write H dash, I'll write H dash as L sin theta into rho G square plus A square in under root plus P naught. And placing the sin theta here now. So L A by G square plus A square in under root into rho G square plus A square in under root plus P naught. Are you समझ में? This gets cancelled. And what are we getting now? We're getting the value of the same point of pressure in terms of A also. A is the acceleration of the container. It comes out to be rho, that was H rho G. This is L rho A plus P naught. Also correct. So everybody, now we know that these two options are correct. And there is one more option which we found which is not there, is also correct. Means what I want your attention on, people. The pressure in terms of G will be in terms of H. The pressure in terms of A will be in terms of L. And pressure in terms of G effective will be in terms of H dash. Are you guys getting this part? Pressure in terms of H has G. Pressure in terms of L has A. Pressure in terms of H dash is G effective, is in terms of G effective. But what is important, you need to remember this. Now the final conclusion is the most important one, everyone. At point A, when I'm writing pressure, the pressure can be written because of the vertical column, can be written because of horizontal column, can be written because of the inclined column also. But you have to take care of which acceleration is along that direction. If you are taking H, the vertical column, then you have to write in terms of G because vertical acceleration is G. If you are writing in terms of L, then you'll have to write in terms of A because horizontal acceleration is A. If you want to write in terms of the slanted height H, then you'll have to take G effective. Now this is something which I cannot write and I cannot just keep on writing this. This is something that you have to keep in mind. The final conclusion, more than the derivation. Because next time we will not do this lengthy derivation only. We will not do this lengthy derivation. Next time only we will directly use it. I will directly say that okay, at A, the pressure if I want to write due to vertical is same as due to horizontal is same as due to the inclined column. Okay, everyone? Happy? Mazaya? Definitely lengthy question, but I'm sure must have been interesting. Okay. Yes, you can say touching to the G advanced level. Okay. So we have got the answer also. Why have I taken two slides here? Yeah. So their approach. I'm not deleting the slide. The approach which is mentioned there. I have kept my three slides also. 1, 2, and 3. Okay. Answer came out to be both the options A and B. Fine. Chalo, everybody. Let's see if you can solve this one or other. This is not even solving. This is only a an easy one for all of you. If the container is given a constant acceleration 8 towards right, then which of these diagrams are representing the correct, diagram representing the correct orientation of the liquid surface in the container? Giving you 30 seconds, and the time starts in 3, 2, and 1. 3 marks. Sure, good. Okay. So we all know we have been solving so many slides we have seen in the previous question, which recommend us to understand that pseudo acceleration is this, G is this, so this is going to be G effective. Okay. So A and G. Okay, everyone. Now the U-tube cases. First of all, don't try to just get into the zone of U-tube. Y-O-U tube. Okay. Actually, the U-tube is a very it's a very scientific term which is given to a tube used in physics and chemistry laboratory. I'm sure you already have a bit of idea of that. May have seen in the laboratories also. And U-tube usually has the shape of alphabet U. That's why it's called U-tube. But not necessarily it has to be the exact U shape. It can actually be two vertical lines and one horizontal line, creating a tube, which will have kind of suggesting shape of alphabet U. The interesting part is we already solved a question last time which had a U-tube manometer in it. Okay. So the idea is very simple. What happens when you have before I even show you this, the idea is very simple, everyone. If I talk about a U-tube, let me try to draw one if I can. Okay. So say this is basically a U-tube. So usually, if I fill any liquid in the U-tube, and both the ends are exposed to the atmosphere. Okay. So here you have atmosphere, and here also you have atmosphere. Can I say that the two ends of the tubes will have the same height in the column? Right. Definitely, because the two layers will always have the same pressure all the time. Okay. But now say one of the tubes or one of the ends of the tubes are connected or closed so that they can create pressure because of a gas. Okay. So now you have gas here. Not necessarily the gas will have the same composition as atmospheric gases. So can I say that now the gas will exert a different pressure? Maybe it will create a pressure Pg, and here the pressure is P atm. So if P, just a second. say this height is now h1 and this is h2. Okay. So if we say that Pg is greater than P atm, so can I say that liquid in the left side will come down and liquid on the right side will go up? By common sense, right? So we will say that h1 will be less than h2. Correct. And if we find that Pg is less than atmospheric pressure, then obviously the liquid on the left side will rise and liquid on the right side will fall. So we can say that h1 will be greater. H1 will be greater than h2. Perfect. Needless to say that if Pg is equal to P atmosphere, then h1 will be equal to h2. Okay, everyone. And that's what happens here. Say in this case they have considered gas pressure is more than the atmospheric pressure. That's why the liquid is pushed more on the side 1 or left side. The liquid is pushed more comparative to the right side. But before, forget about what is written in the text. Just try to understand the logic. You'll get it very easily. What will you say about the pressure at point 1 and 2? What will you say about pressure at point 1 and 2? Should be same because they are at the same level. They belong to the same liquid. The liquid is mercury maybe. So this is mercury. Okay. So this is what is written. P1 will be equal to P2. P1 is because of gas. Pressure at 1 is because of gas. Do you agree? The pressure at 1 point is because of gas. But pressure at 2 is because of atmospheric pressure and H rho g, both. Liquid column and atmospheric pressure. Both are creating the pressure at point 2. So that is what is written. Atmospheric pressure plus H rho g. Okay. So how do we calculate the gas pressure? We do not know what is the pressure which is exerted by the gas, but we do know the value of atmospheric pressure, 1.01 into 10 to the power 5. And we can physically, with our eyes, we can see the value of this height h. We know the density of mercury and we can multiply it by g. So this is an artificial intelligence to find out the gas pressure, P0 plus H rho g. Okay. Yes. And obviously the gauge pressure is only this one. I need not tell you what is gauge pressure anymore. You already understand. So that's the idea of YouTube. We solved the question already last time on this. I hope you people remember. Okay. Height can be in centimeter, can be in meters also. Depends which unit system you are using and which unit system the question is asking you. Only thing that I want you people to remember, try to keep all the quantities in the same unit system. Okay, everyone. Let's have a look at examples and questions before we say the wrap up. Okay. Sure. Yeah, YouTube word came from laboratory. So everyone, see this. You have a YouTube. In which instead of having one liquid now, you have two liquids. So instead of creating a gas on the left hand side, they have kept two liquids only, which are different. The density of the first or the green liquid is 2 times rho, and on the blue liquid, the density is rho. The length of the height of the two columns is same, maybe at the moment. At the moment, it is same, and the length of the horizontal column is also L. Question is saying, if the two liquids which do not react chemically are placed in the bent U tube, find out the displacement of the liquid X in the equilibrium position. So that they are suggesting that this liquid is going to come down. If the left side liquid comes down by X, what will be the amount by which liquid will rise on the right side? Definitely X. The constraint, that's the constraint. Incompressible liquids. Ideal liquids. These are all ideal fluids. Remember, we are studying ideal fluids as of now. We're not studying real fluids yet. Okay, good. So we'll have a look at this, everyone. So if I want to find out the value, I will say that both the surfaces or free layers are exposed to the atmosphere. So here also atmospheric pressure acting, here also atmospheric pressure acting. So on this side, if I want to write down the pressure at A, before I even solve, what will you comment about pressure at A and B? Are they same? Are they same? PA and PB, are they same? PA and PB, are they same? That's the question that I'm asking you people to respond in the hotspot quickly. 3, 2, 1, and the time is up. For two same layer points to have the same pressure, the liquid should also be same. For two layers to have the same pressure, the liquid should also be same. Okay, you can see that they don't have the same density. Okay, please remember, don't remember only half the things. Okay, people. So at A, okay, if they would be at the same pressure level, definitely the height difference will not come because of atmospheric pressure then, because the same pressure is acting on the free layer, because they do not have the same density. That's why the liquid on the right side has risen up so that it can balance this atmospheric pressure at this point. So anyway, guys, this is what has happened earlier. The liquid was supposed to be at this, this level, red level that I've drawn. So now this has gone down. So at this point A, if I want to write down the pressure, I say that at point A, okay, not point A, in fact, point A and B definitely did not have the same pressure. What do they say? The pressure at interface must be same. Calculate it via either tube. Since both tubes are all open to the atmosphere, we must say that 2 times rho g into L minus x should be equal to rho g into L plus x. Okay. So what they're trying to say, if I consider this layer or consider that this gap is negligible. Everyone, can I say that the bottom of the container will definitely have the same pressure? Doesn't matter which two different liquids are there. The bottom of the container should have the same pressure, right? So just neglect this gap, okay? Neglect this gap delta x, right? Because then otherwise the container will have different points which are at different pressure. So shape of the container will vary. So assuming that the solid body has the same amount of pressure exerted so that it maintains its inclination being horizontal. Okay. So everyone, now you can understand that the pressure at the bottom because of 2 rho, which has a height of the liquid column as L minus x, means just to make it look indeed the way it should be. We are saying that this is L minus x and this is L plus x. Now it should make sense. Okay. So point A and point B. So PA equal to PB. At A, the pressure is P naught or P atmosphere plus 2 rho into G into L minus x. Okay. On the right hand side, the pressure at point B is density rho into G into L plus x. Obviously, and plus P atmosphere. the atmosphere gets cancelled throughout or both the sides. Multiply 2 rho g inside and rho g also inside. So 2 rho gl minus rho g, 2 rho gx. Here it is rho gl, rho gx. Take this 2 rho gx on the right hand side. X wala term will become 3. L wala terms will remain only 1. Rho into g gets cancelled. X comes out to be L by 3. Tell me it makes sense? Everyone? Understood? Then you need to try one question. A similar question. Doesn't require Pascal pressure. We don't even know what is Pascal's law. I do not even know what is Pascal's law. Right? As of now, I do not know what is Pascal's law. Yeah. Anyway, just a second, everyone. Okay, everyone. Question for all of you guys to try now. Let's read the question first. We have been given a U tube which has uniform area of cross section. It contains mercury on both the sides. Okay, this one. This is basically the mercury whose density I have written 13.6 gram per centimeter cube. And what they do on the right hand side here, they fill glycerin. Glycerin is a type of a liquid, and its density is 1.3 grams per centimeter, and the height of the column is 10 centimeter. Okay, and on the left side of the arm or left side of U tube, they put some oil. Okay, whose density is 0.8. So because of this, what happens? There's a difference which should be created. But what does it do? They say that the amount of the glycerin and amount of oil is such that the free surface that you see at D and A, they are at the same level. Okay, that's what they say. Until the upper surface of oil and glycerin are at the same horizontal level, they have managed to balance this out. Question is asking us that if the glycerin was 10 centimeter height column, what do you think to what height should I fill the oil so that I can have the free surfaces to be at the same level? Okay. Hint that I can give you to find the value of H or whatever you want to do here. I can tell you that if this is 10, this is 10 minus H. Okay. And think from Mercury's point of view. Think about Mercury and then try to find the answer. Okay. I'm giving you guys complete 2 minutes for this, and your time starts in 3, 2, and 1. You have to find 2 points which are at same pressure. That's okay. And think from Mercury's point of view. Think about Mercury and then try to find the answer. Okay. I'm giving you guys complete 2 minutes for this, and your time starts in 3, 2, and 1. You have to find 2 points which are at same pressure. That's another hint. You have to find 2 points in the tube which have the same pressure. Last 10 seconds now. Meanwhile, in the chat box, which are the 2 points which have the same pressure? Which are the 2 points which have the same pressure? A and D, do they have same pressure? A and D definitely have the same pressure because they are exposed to atmosphere. They are exposed to atmosphere, but they are useless. They are useless. A and B have the same pressure, but useless. I can just say that, okay, they have the same value of pressure, that is atmospheric pressure. How about E and B? How about E and B? Do they belong to the same liquid? Do they belong to the same liquid? Do they come in mercury? They come in mercury? They belong to mercury. Okay. So point E and point B have the same pressure. So pressure at E is because of 2 liquids. Pressure at B is only because of 1 liquid. Okay. So see, pressure at E is obviously they have just removed the atmospheric pressure part because on both the side that portion or that part will get cancelled out. That's why in the written solution P0 is not written. So look at this. Now we know how to write the pressure because of 2 liquids also. In the beginning of today's session we did this. Yeah, H1 rho 1 G plus H2 rho 2 G. Right? That will be used here. H1 rho 1 G plus H2 rho 2 into G. right? So H into 0.8 into G. 0.8 is the density of the oil, and 13.6 is the density of mercury into G. And on the right hand side, the density of glycerin is given to us as 1.3. So height of that 10 centimeter. That comes out to be H into rho into G. G will obviously get cancelled. First you will cancel P naught, then you will cancel G, and you will simplify this. Can you do the maths for yourself? The answer will come out to be 9.6. Okay. Yep. This brings us to the end of the session as well. Let me show you the leaderboard. Good job, guys. Good job. Ishika, Sumit, and Krishna are the top 3 today in the leaderboard. Then we have Nanda, Akshat, Arya, Arihant, Harsh, Harshita, Adesh, Krish, Adi, Tejas, Sandeep, and Paridi. So good job, guys. This is for all of you, not just the one who are there in the leaderboard, but for everybody, as always. Okay, and great, nice. Okay, so this brings us to the end of the session. Abhi bolo. Thank you, Priyanshu. Sir, tomorrow is my birthday. Happy birthday in advance, Aditya Sharma. Thanks, let's wish him quickly. Yes. This is for you, Aditya. You guys have class tomorrow also. That's good. Thank you guys. Yes, thank you so much. मेरा birthday है day after. और आलिक का है day after. Thank you everyone. So doubts. Doubts पूछो. So if a liquid has specific density as 2, then the density of liquid should be 2 into 10 to the power. ये doubt है ना. So Aditya. Yeah, specific density or relative density is a relative term. It does not have units. मैं तुम्हें आइडिया दे देता हूँ. जैसे डेंसिटी ऑफ मर्करी होता है 13.6 into 10 to the power 3 kg per meter cube. ओके, डेंसिटी ऑफ मर्करी एंड डेंसिटी ऑफ वाटर होता है 10 to the power 3 kg per meter cube. दोनों का रेशियो लो. ये कैंसिल हो गया. आंसर क्या आया? हेलो. Yes, those who want to exit the session can exit. Class teachers, you can also exit the session once you are done explaining the route. Now, ये वैल्यू थी kg per meter cube में. अगर मान लो मैंने डेंसिटी लिखा Hg 13.6 ग्राम पर सेंटीमीटर क्यूब, तो मुझे डेंसिटी ऑफ वाटर भी ग्राम पर सेंटीमीटर क्यूब में लिखना पड़ेगा. Now take the ratio. Does it change the answer? Exactly. So answer. डाउट पूछो ना उसमें. बहुत बार मैं प्रोसेस नहीं कर पाता हूँ. तुम सीधा डाउट बताओ उसमें क्या डाउट आ रहा है, किस पॉइंट पे डाउट है. जो कैलकुलेट करनी है क्वांटिटी, उसके ऑप्शंस एसआई यूनिट में है या सीजीएस यूनिट में है. मिलीमीटर में दिए हुए ना. तो तुम्हें भी जो डेंसिटी दे रखी है, जो वैल्यू तुमने निकाली है, तुम अज्यूम करोगे कि तुमने एसआई यूनिट में निकाली है. तो मिलीमीटर में कन्वर्ट करने के लिए तुम्हें उसको उसकी रिलेटिव डेंसिटी है ना, तो तुम्हें मानना पड़ेगा. हाँ भाई, उसको उन्होंने एसआई यूनिट में लिखा है, इसलिए टू रिलेटिव डेंसिटी है. ये वैल्यू है वो 13.6 दे दिया, लेकिन डेंसिटी ऑफ मर्करी कभी भी मैं 13.6 नहीं लिख सकता ना, क्योंकि इसका मतलब हुआ कि मुझे पता ही नहीं यूनिट्स क्या है. तो यूनिट्स जब मुझे लिखनी होगी तो मुझे हमेशा मल्टीप्लाई बाय डेंसिटी ऑफ वाटर भी करना पड़ेगा. तो वो जो 10 to the power 3 लिखा है वो डेंसिटी ऑफ वाटर लिखी हुई है. क्यों लिखी है? क्योंकि रिलेटिव डेंसिटी तुम्हें बताइए, स्पेसिफिक ग्रेविटी तुम्हें बताइए, इसलिए. स्पेसिफिक ग्रेविटी उसमें दे रखी है 2. हाँ, तो 2 into 10 to the power 3 होगा. 2 into 10 to the power 3 होगा. बिल्कुल बिल्कुल बिल्कुल. एक्चुअली स्पेसिफिक डेंसिटी कोई टर्म ही नहीं है. या तो रिलेटिव डेंसिटी कहलाती है, और अगर विद रिस्पेक्ट टू वाटर निकाला तो स्पेसिफिक ग्रेविटी कहलाती है. ठीक है. ओके. In slide 27, will filling air inside a balloon will be contradictory example of option B. एक मिनट. 27. I think you want to speak about this one. है ना तुषित? Liquid will always try to accommodate as much volume as it can. Tushit, let me put it this way. In order to do that, it will try to create space. If that thing is outside the liquid, it will try to push it away. If that thing is inside the liquid, it will try to compress it, but it will try to create more space for itself. That's what it will try to do. Okay, Tushit? Yes, good evening. Good evening. Last question. Last one. Tell me more. I'm not able to understand what you're saying. If you take what? If you take what? In the YouTube. Bottom. YouTube of U shape or YouTube of this shape. This portion will be considered to have the same pressure. Yes, but considering that this is a solid surface, its shape remaining intact, that's why we are considering the pressure at this layer will remain the same. The solid surface, yeah. Okay. Good evening. Do you see right angle triangle ADB? Which one is the hypotenuse here? L is the hypotenuse. Which one is the adjacent side here? H dash is the adjacent side. It is not. That one is actually written for the green line. So actually that has not been written only. So what is the perpendicular side or opposite side? So how will you write sin theta in this right angle triangle? ABD. Will it be H dash by L? Okay. That's what is written here. Okay. हेलो हाँ सुधीर DL वाई डेल मतलब ताकि क्योंकि मुझे दिया नहीं है ना वो कितना हाइट है उसका दिया नहीं है इसलिए थोड़ा और दूर जाके बात करो ना माइक्रोफोन से और दूर जाओ माइक्रोफोन से तुम सच में दूर जा रहे हो माइक्रोफोन से अब बोलो एक्चुअली मैंने जब सॉल्व किया अब इस वाले पॉइंट से इंडिपेंडेंट बना दिया था मैंने सोल्यूशन को मैंने मेजरमेंट की बॉटम मोस्ट पॉइंट से ले लिया तो इवन इफ इट इज नॉट डजंट मैटर इवन इफ दिस इज नॉट नेग्लिजिबल इट्स नॉट गोइंग टू अफेक्ट इट ओके मैंने बॉटम मोस्ट पॉइंट की मेजर कर दिया ओके obviously center of mass का लोकेशन मास पे डिपेंड करता है सेंटर ऑफ मास इज नथिंग बट द टोटल मास ऑफ द बॉडी एट व्हाट क्या हाँ एक की शेप में बॉडी कंसीडर की आधा क्या मतलब एक शेप की बॉडी है और उसमें तुम बोल रहे हो नीचे से या ऊपर से हाँ तो h हाइट तक बोलो तो हाँ बढ़िया ठीक है ऑब्वियसली मास ही डिफरेंट हो गया अब तो ऑब्वियसली सेंटर ऑफ मास अगर इसमें यहाँ पे आया तो जब तुम क्वांटिटी कम कर दोगे तो सेंटर ऑफ मास को नीचे आना ही पड़ेगा ये सुनो अगर तुम दो सेम मास की बॉडी को कंपेयर करोगे तो सेंटर ऑफ मास तब भी अलग अलग पॉइंट्स पे लोकेट हो सकता है डिपेंडिंग अपॉन द शेप ऑफ द बॉडी डिपेंडिंग अपॉन द शेप ऑफ द बॉडी दो सेम मास की बॉडीज का सेंटर ऑफ मास जरूरी नहीं है सेम पॉइंट पे आए गेटिंग तुम तो कंपेयर दो अलग अलग मास की बॉडीज को कर रहे हो तो फिर तो यार बहुत सारी पॉसिबिलिटीज आ गए डेंसिटी पे बहुत कुछ डिपेंड करेगा तो यहाँ तो मैं डेंसिटी सेम मान रहा हूँ इसलिए मैंने बोल दिया कि अगर सेम लिक्विड था अगर लिक्विड खाली होता जाएगा तो सेंटर ऑफ मास भी तो नीचे आता जाएगा ओके ओके विहान 2 मिनट यस तुषित बोलो एक्चुअली यू आर नॉट रॉन्ग जो तुम बोल रहे हो इसी पॉइंट ऑफ व्यू से देखा जाए तो थोड़ा सा पॉइंट ऑफ व्यू वाला जो पॉइंट है उसके बेसिस पे प्रेशर कैन आल्सो ट्राई टू एक्सपैंड द बॉडी राइट प्रेशर कैन आल्सो ट्राई टू एक्सपैंड द बॉडी तो आई वुड से एम्बिगुअस है स्टेटमेंट एम्बिगुअस एक्चुअली अगर इन्होंने डिफाइन कर दिया होता कि लिक्विड के अंदर एक बॉडी रखी है तो कंप्रेसिव ही है फॉर श्योर इसलिए मैंने क्लैरिफिकेशन में तो यही बोला कि लिक्विड विल ऑलवेज ट्राई टू ऑक्यूपाई मैक्सिमम वॉल्यूम तो अब उसे एक्सपैंड होकर करना पड़े या किसी चीज को कंप्रेस करके करना पड़े बिल्ड होता है ओके बट यू आर राइट इन द थॉट प्रोसेस ओके थैंक यू शिखा यस विहान यस टेल मी गुड इवनिंग बोलो बढ़िया बहुत अच्छा हो गया तो हम्म, जब ये डर आता है ना तो ये सोचना कि जेई का एग्जामिनेशन आएगा तब मैं क्या सोचूंगा फिर क्या ये एग्जाम जेई के एग्जामिनेशन जितना डिफिकल्ट है या क्या ये उतना ज्यादा इंटिमिडेटिंग है या वेदांतु के एग्जाम्स एक्चुअल जेई के एग्जामिनेशन जितने इंटिमिडेटिंग होंगे या तुम्हारा नर्वसनेस का लेवल जो जेई के एग्जाम के दिन होगा क्या वो इन एग्जाम्स में होता है थोड़ा तो होता है पर तुम्हें लगता है कि जेई के एग्जाम के दिन हाँ पर तुम्हें लगता है कि जेई के एग्जाम के दिन तुम्हारा नर्वसनेस लेवल इससे कम होने वाला है ज्यादा ही होगा ना हाँ तो बस फिर ये वाला एग्जाम तो फिर कुछ भी नहीं है उसके सामने बल्कि हम एक्चुअली उस दिन नर्वसनेस कम हो इसीलिए ये नेट प्रैक्टिस कर रहे हैं ये जो हर अल्टरनेट संडे होता है ना सब यहाँ है इट्स ऑल इन हियर इसलिए मैं बोल रहा हूँ बोलते ना बहुत बार अपने वो जो मूवी है ना कौन सी 3 इडियट्स 3 इडियट्स में जो आमिर खान ने बोला है कि ये जो दिल है ना इसको बहला के रखना पड़ता है यू हैव टू एक्चुअली मेक अ फूल आउट ऑफ इट यू हैव टू टेल इट यू नो एवरीथिंग इज ओके एवरीथिंग इज ओके दैट्स द ओनली थिंग दैट यू हैव टू टेक ओके थैंक यू बहुत सारा शुक्र कल मेरी क्लास तुम्हारे बैच में है हाँ ठीक है ओके थैंक यू टेक केयर बाय बाय यस रिद्धिमान बोलो बच्चा हाँ नहीं मैंने वो मूवी नहीं देखी हाँ हाँ और फिर आगे क्या होता है उसमें पहली बात तो बहुत ही ओपन एंडेड क्वेश्चन है क्यों हमें तो मालूम है इवेंचुअली सचिन तेंदुलकर को बॉल को प्रोजेक्टाइल मोशन में भेजना है अब प्रोजेक्टाइल मोशन में भेजने के लिए एंगल थीटा क्या है वो नहीं बताया, क्योंकि थीटा बहुत इंपॉर्टेंट है चक्कर मारने के लिए। बोल दिया 45 डिग्री। तो 45 डिग्री के लिए अगर बॉल आई तो बॉल की वेलोसिटी मान लेते हैं कांस्टेंट है, जो बॉल आई वो कांस्टेंट वेलोसिटी से है, ठीक है। बॉल प्रोजेक्टाइल मोशन में जाने से पहले कोलिजन में जाएगी, इट विल कोलाइड विद द बैट। तो कोलिजन के बाद उसकी क्या वेलोसिटी होगी हमें वो फाइंड आउट करना पड़ेगा, अज्यूमिंग मे बी इलास्टिक कोलिजन, अज्यूमिंग की बैट डज नॉट मूव, तो बॉल आई कोलाइड होके गई, अज्यूमिंग की वेलोसिटी रिमेन्स अनचेंज्ड ऑफ द बॉल, वेलोसिटी मतलब स्पीड रिमेन्स अनचेंज्ड। मैं मान लिया कि जिस स्पीड से शोएब अख्तर ने बॉल की थी उसी स्पीड से बॉल बैट पे लगने के बाद भी जाने वाली है। उससे तेज जाने के लिए तो फिर सचिन तेंदुलकर कितने फास्ट बैट को घुमा रहा है वो भी हमें मालूम होना चाहिए, द वेलोसिटी ऑफ द बैट, क्योंकि दो ऑब्जेक्ट कितनी स्पीड से कोलाइड कर रहे हैं उसके बाद फाइनल वेलोसिटी उन दोनों की इनिशियल वेलोसिटी पे डिपेंड करती है। और मैं क्यों नेगलेक्ट कर रहा हूं, क्योंकि सचिन के बैट का मास भी चाहिए होगा, क्योंकि दो ऑब्जेक्ट कितनी स्पीड से कोलाइड कर रहे हैं उसके बाद फाइनल वेलोसिटी उन दोनों की इनिशियल वेलोसिटी पे भी डिपेंड करती है। और मैं क्यों नेगलेक्ट कर रहा हूं, क्योंकि सचिन के बैट का मास भी चाहिए होगा। मैं कोलिजन में तो लॉ ऑफ कंजर्वेशन ऑफ मोमेंटम लगाऊंगा ना, तो मास भी चाहिए, ना बॉल का मास दिया है ना बैट का मास दिया है, मैं अज्यूम करूंगा सिंपलेस्ट कि भाई काइनेमेटिक्स से सॉल्व करना है मुझे, तो बॉल आई जितनी स्पीड से आई उतनी स्पीड से गई और 45 डिग्री एंगल पे गई, तो u square by g इज द आंसर। r will be maximum when it is u square by g, that's it. Now sir, I am not getting time to solve any other book than we dream of solving. यार मैंने कल ही आंसर दिया है आराध्या, इस क्वेश्चन का आंसर मैंने कल ही दिया है। हर्षन आई थिंक asked me this question, so I have answered this already. Were you there in the class yesterday, Aradhya? So just watch the last 20-25 minutes, last half an hour of the class yesterday. I have given the answer. Okay. हाँ विहान बोलो। Come again? अरे बर्थडे तुम्हारा है कि मेरा है? तो केक तो मेरे पास आना चाहिए ना। हाँ बर्थडे बॉय से केक नहीं मांगते, बर्थडे बॉय के लिए केक लेके आते हैं। चलो गुड वन, चलो बाय बाय। Okay everyone, वैसे भी आजकल क्लास कैन ओनली बी एक्सटेंडेड फॉर हाफ एन आवर, इट विल ऑटोमेटिकली गेट डिस्कनेक्टेड और एंडेड। आई होप एवरीबॉडी गॉट द आंसर्स ऑफ द क्वेश्चन दे आस्क्ड। इशिका ने पूछा था सर लो मार्क्स आते हैं तो कॉन्फिडेंस गिर जाता है, फिर टेस्ट देने का मन नहीं करता। यार इट्स लाइक अगर आजकल विराट कोहली इज नॉट मेकिंग रन्स, विल ही स्टॉप प्लेइंग क्रिकेट? Ishika, Ishika, do you know Virat Kohli? First of all, I have to actually ask this to the girls also because usually girls don't like to watch cricket. So you watch, right? So Virat Kohli has stopped performing as he used to perform, but will he stop playing cricket? He will not. Instead, what he has done? He has done this. He has done this. That means what? Instead of putting your efforts at multiple places, try to channelize your energy. Try to channelize your energy. Try to keep your focus on limited things. One of them would be the answer to Aradhya's question. Please put your focus on only solving tattva. Please put your focus only on solving tattva. Okay? Aradhya, solving tattva is like solving 5 different books. Let me put it very simply and straightforward. Now you don't need to watch that previous class replay. So you have to tell yourself, if I do not go for this next test because I did not score well, then I'm actually ensuring that I'm going to get weaker and weaker and weaker. I'm not definitely going forward without. Means it's like again in the cricket only. If the batsman is not confident, he'll start playing back in the back foot. You don't want to play on the back foot, yeah. You want to make your career. Now remember, your career is directly proportional to your confidence. If you play on back foot, everybody will take a lead over you. You don't want to play on back foot. Whatever happens in the test, I'm appearing for the test. And I'm telling my parents that this is still new for me. I'm still learning. I'm still performing. And I'm telling you, your parents will always be, they'll always be supportive. They'll never say that, why your marks are not coming? Why are you preparing for JEE examination? They'll not. Okay. Vihan, were you not there in the guidance session? In the guidance session, I gave you only 3 tips. The first step is the answer to the question of motivation. And that is your own reason why you're preparing. Now, parents, so alternate suggestion tha. If you have your reason clear, that's good. If you do not have, do it for your parents. So if you feel demotivated, just think about your parents, that you're doing it for them. Okay? The motivation will come back. Yes. Okay. Okay, thank you everyone. Thank you once again. Time to wrap up. Let's meet next week. Till then, take care. Thank you once again. Thank you so much. Love you all. Signing off. Bye bye. Thank you. Thank you. Thank you. Enormous times. Thank you. Bye bye. Signing off. Yes. Thank you.